We'll continue this discussion by looking at one final example for determining valid arguments using truth tables. So in this example, our statements read, if we leave now, then we can beat the traffic. If we beat the traffic, then we will be on time for the movie. Therefore, we'll be on time for the movie if we leave now. Now remember that we begin with looking for our conclusion in the statements. So the conclusion typically follows a word like therefore. So our conclusion will be, we'll be on time for the movie if we leave now. So I'm going to type that in the conclusion. But when I do, most of the time when we have an if-then statement, the if part of that statement comes first. So I'm going to write this in the correct order. So it says we'll be on time for the movie if we leave now. So I'm going to start with if we leave now, we will be on time for the movie. So I'm just turning that around so that it'll be a little bit easier to work with. Okay, premise 1 and premise 2 then will be the other two sentences. Premise 1 will be the first sentence, which says if we leave now, then we can beat the traffic. And premise 2 says if we beat the traffic, then we will be on time for the movie. All right, so now we have identified the three sentences, labeled them premise 1, premise 2, and the conclusion. We're now ready to translate them into symbols. So remember that the easiest place to start is with your first premise in terms of your symbols. So the first premise is an if-then statement. And so we've talked about finding the then, and looking to the left to identify the P, and looking to the right to identify the Q. All right, so I am going to say then that the P statement is we leave now. And the Q statement is we can beat the traffic. All right, so if I have labeled it that way, then I can take the first premise and I can say P, which is we leave now, arrow, which is the then, and then the then part will be we can beat the traffic, which we identified as the Q. So we can take that first sentence and translate it into P arrow Q. All right, let's look at our second premise. It starts with, it's also an if-then statement, and it starts with if we beat the traffic. So that is going to be the Q, and then we have an arrow, and then we have this part. We will be on time for the movie. Now, I haven't assigned a letter to that situation. P is we leave now, Q is we can beat the traffic. We haven't said anything about being on time for the movie. So I'm going to give that a third letter. That's going to be my R. So we will be on time for the movie. All right, and so we'll add that in right there. So we have Q arrow R. All right, and then let's look at our conclusion. Our conclusion is also an if-then statement. And so it starts with if we leave now. So that's the P. Then we'll be on time for the movie. So that is the R. So now we've translated the three statements into letters. The next thing we need to do is put them together into a statement that we can do a truth table for. So remember how this works. We do premise 1 and premise 2 connected with the and symbol. All right, so premise 1 is P arrow Q. Premise 2 is Q arrow R. And I've used the and symbol in between. Then the conclusion, we use this double arrow, which stands for implies, and we write our conclusion down, P arrow R. And so it is that statement that we're going to be working on constructing on the next slide for our truth table. All right, so I'm going to write that statement at the top for our reference. So we have P arrow Q and Q arrow R. We have our implies arrow, and it implies P arrow R. And then we're ready to do our truth table. All right, so this one has a P, a Q, and an R. So we'll do our standard 3 columns for those letters. We know that the P column has half and half trues, half falses. So that's going to be 4 T's followed by 4 F's. The Q column goes to 2 and 2. So 2 trues, 2 falses, 2 trues, 2 falses. And then the last column alternates every different one. So true, false, true, false, true, false, true, false. Okay, so let's start building this truth table. We're starting on the left-hand side. We'll work on the P arrow Q. I have a P column, I have a Q column, but what I don't have is a P arrow Q column. So let's do that first. So I'm going to copy my P values from here underneath the P. I'm going to put my symbol, which is the arrow, and then I'm going to copy my Q values. So that's going to be true, true, false, false, and so forth. And we're going to use our table for if-then to answer these statements. So I know that on my if-then table that this is my false case, but that every other scenario is true. So I'm going to go ahead and fill in the rest with trues. All right, and so now we're ready to move on. The next thing we'll work on is the Q arrow R. So again, we have a Q column, we have an R column, but we don't have a Q arrow R column. All right, so let's start by copying. Let's do the Q's. So I'm going to get those from here. So I'll copy those underneath. T, T, F, F, T, T, F, F. We'll put our arrow symbol in between. And then we're going to copy the R column. So the R column will get copied from here. TF, 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 all the way down. And again, these are if-then statements, so we'll go back to our if-then chart and we'll look up our statements if we don't know them yet. And we'll write our answers down. Now, I'm keeping in mind that the only way an if-then statement can be false is if it starts with true and then it goes to false. So like that one is false. This one is also false. But everything else in the table right now is true. Okay, so the next thing that we need to do is we need to put those together to form the entire left-hand side. So I'm going to do P arrow Q, the and symbol, and Q arrow R. And again, we'll do some copying. So for P arrow Q, we're going to copy the answers that we got right here. So true, true, false, false, true, 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 true. And then we'll put our and symbol in. And then for the Q arrow R, we're going to copy the answers that we got right here. So true, false, true, 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 false, true, true. All right, so for that, we'll go to the and table. We'll look up these answers. We know that on the and statements, they both have to be true in order for them to be true. Okay, but we do have a lot of those cases. This one is both true. This one is both true. And these bottom two will also be true. And then the rest of them will be false. So that completes the left-hand side of the statement. So now we'll move on to the right-hand side. So I need to do P arrow R. So again, we'll copy the P values down. So we have 4 trues and 4 false values. We'll put our symbol in between, which is the arrow. Then we'll do our R values. So we'll copy the R values down. And so we'll then go back to our if-then chart and we'll look up the truth values for these statements. So we know that true arrow false is false, and every other case is going to be true. All right, so that takes care of the right-hand side. We're now ready to put the entire statement together and come up with our final answers. So I'm just going to write our entire statement up here. All right, so for this part, we're going to come right here and copy those answers over. So true, false, 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 true, false, true, true. Then we'll put our symbol in, which remember that double arrow in this last column goes to an arrow, goes to an if-then statement. And then we'll copy the answers that we got for P arrow R. So that will be these answers. So true, false, true, false, and then true on the last four. And now we're ready to write down our final answers. So these are all if-thens. Remember that the only way an if-then statement can be false is if it starts with true and it implies false. And I don't see that statement here at all, the T arrow F. So I think that all of these statements are going to be true. And so our final answers will all be true, which leads us to call this a tautology. And more important in this section means that we have a valid argument.